Hello class, today we're looking at congruent triangles. So the essential question is, how do I identify congruent triangles and find missing measures? Your learning intention. I'm learning to identify congruent triangles and use CPCTC to find missing measures. Last class period we looked at CPCFC, which was corresponding parts of congruent figures are congruent. Now we're going to look at TC, which is corresponding parts of congruent triangles are congruent. So you've got 4 warm-up questions. Pause the video and see if you can do those 4 warm-up questions now. Well, I hope you tried. If we're looking over here, there's no measures, but we know that KLMJ is congruent to TQRS. If I am looking for the measure of angle Q, I notice that Q is the second letter here. So the second letter here is L. That means angle L and angle Q are congruent. Angle L is 86 degrees. Angle Q will be 86 degrees. The measure of angle S. Angle S is the last letter. The last letter is J, so I find angle J. J is 149 degrees. That means S is also 149 degrees. Okay, let's look at QT, the measure of QT. QT are the first two, KL are the first two. KL is 40 feet. QT is also 40 feet. Okay, can you do QS on your own? Oh, if you told me there is no QS, it doesn't exist, you would be true. So there is no QS. If you're looking up here, Q is followed by R, and T is before Q. That means the two segments with Q are TQ and QR. There is no QS. Okay, there are 5 different triangle congruencies. The first one, if 3 sides of a triangle are congruent to 3 sides of another triangle, then the triangles are congruent by. SSS is the correct answer. If you notice, these are called tick marks. This one has tick marks, which means this one with tick mark is the same length. 1 tick mark, 1 tick mark. Those are the same length. 2 tick marks, 2 tick marks. Those are the same length. 3 and 3. So you look at the number of tick marks to tell you if they're congruent or not. Okay, looking at the next one. If 2 angles in the included side, what does the word included mean? It means the side that connects the 2 angles are congruent to 2 angles in the included side of another triangle, then the triangles are congruent by. What does it start with? Angle, side, angle. If you notice, the included side is that side in between. This angle has 1 arc. This angle has 1 arc. That means that B is congruent to E. C has 2, F has 2, C is congruent to F. And we know that D will be congruent to A because of the triangle sum theorem. So this is angle, side, angle. Okay, now we're going to 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle. then they're congruent by what? Side, angle, side. Two tick marks, congruent. One tick mark, congruent. Your angle in between is congruent. Side, angle, side. Okay, the next one. If two angles and the non-included side of one triangle is congruent to two angles in the non-included side of another triangle, then the triangles are congruent by angle, angle, side. Okay, the side angle side and angle side are very, very similar because we know if two angles of one triangle are congruent, then the third have to be congruent because the triangle sum theorem states the sum of the angles of the triangle add up to 180 degrees. So these two are very similar using the same idea. So side, 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 angle, angle, side, angle, side, angle, angle, side. There is no angle, side, side. Think of what the word means. Don't use it. Okay, the last one works only for right triangles. If two right triangles have a congruent hypotenuse and leg, then they are congruent by, this is our HL, hypotenuse leg theorem. If you look over here, they're right triangles. Here's your hypotenuse. Your hypotenuse is the longest side. It's straight across from your right angle. And then you've got one leg that is the same. Okay, we're looking at determining whether the triangles are congruent or not. How can we prove it? After we prove it, what does a statement look like? The congruent statement, which states one triangle is congruent to another. Well, let's take a minute and look at the first one. I've got angle U is congruent to angle T. I've got angle USV is congruent to angle TSV. And they share this side, which means they have to be congruent. So this is by angle, angle, side. See, triangle SUV is congruent to triangle. Okay, S. Now U has 2, so I've got to go from S to T to V. See how we match up the corresponding parts. U matches T. S matches S. And so forth. Okay, look at the next one. We've got two sides marked. We don't know anything about the third side, so we know it's not side, side, side. Do we have any angles that we can prove are congruent? Okay, I've got these intersecting lines. I've got these angles in here, which I know will be congruent because they are what? Vertical. Okay, these are vertical angles. I didn't get that written very good, did I? Vertical angles. Okay, let's look at what we've got. We start with a side, then we go to an angle, and then to another side. So this is bi, side, angle, side. Okay, this is V in the middle. STV, triangle. STV is congruent to triangle. S to V, S to T has nothing. So I go from nothing to 1 to 2. Go from nothing to 1 to 2. So nothing here, 1 tick mark, 2 tick marks. RU, V. Any questions? Okay, how about the next one? What do we know from the picture? We know that there's one angle that's congruent. Do we know anything else? We know that these share a side. Okay, that's 2 pieces out of 3 that we know. Is there any way to prove another angle or another side? No. So these are not necessarily congruent. We're going to start using our congruent symbol more. Okay, for the last one. Okay, because it does not have the vertices marked, I need to do that first. So I'm going to call this triangle, rectangle, A, B, C, D. You notice I go in order. So what do I know? I know I've got a side here. I know nothing about the angle, but this side is also congruent to itself. So this would be angle, side, side. Would it be congruent? No. Okay, so 2 of them were congruent, 2 of them not necessarily. If we knew that this angle was congruent to this angle, we could use side, angle, side, or angle, side, angle, either one. But we don't know that, so we cannot assume that that is a true statement. Okay, now, pretend we want to make these triangles congruent. Okay, I know that these are both right triangles. I know that 41 is the what over here? It's the hypotenuse. I look over here. What is the hypotenuse over here? It's W. So we know that W has to be equal to 41 for the hypotenuses to be congruent. Okay, if I am looking, I've got a side measurement of 18, I've got V. V has got to be equal to what number for them to be congruent? 18 is correct. If that happens, we know that triangle STU will be congruent to triangle. Okay, from S to T is 18 and then the hypotenuse. DFE. Okay, from S to T is 18. From D to F is 18. From T to U is 41. From F to E is 41. You match up those pieces in your congruent statement. And this is congruent by hypotenuse leg. So, how do you know when you're successful? You know you're successful if you can identify which triangles are congruent and find the missing measures when the triangles are congruent. So these are your congruences of triangles and finding missing measures.